folks. I was recently at LibrePlanet, which is a conference put on by the Free Software Foundation, the makers of GNU, among other things. And I gave a small tutorial about using Python in Blender as my talk there. And I thought it'd be fun, instead of putting slides online, since a lot of people were asking for Python tutorials, to do this as a online tutorial and simplify it a little bit and focus it more on people who already are users of Blender who want to pick up some Python skills. And the topic of the tutorial was quite simple. It was to create an Add GNU button. Since GNU is the name of the OS made by the FSF, and their mascot is I'll show you. It's this simple GNU head. If you add a subserve to it, you'll be able to see it more clearly. So it's a simple GNU head mascot. And since Blender already has in its primitives to add, it already has a nice add monkey. I wanted to add this add GNU button using an add-on. So let's dive in and see how to do that. So the add-ons have a bunch of boilerplate, right? So you need to add an operator that will give you the add mesh functionality that you're looking for, and then you need to create a button for it and then you need to add that button into the menu over here. Finally, you have to wrap that in a bunch of data that tells Blender that this is an add-on with a certain name and some data and registration functions. And then, all of this gets added together, making a script quite complex and big. And it's really hard to remember what all those, those boilerplate functions have to look like, and, the different classes that you need to make, and so on and so forth. And so in order to make this easier, Blender has this nice templates that you can use. So if you go to a text editor in Blender, you can go templates, Python, and there's so many of them. And the first one is add-on add object, and it has everything you need to start adding your own primitives into Blender. Everything you need entirely. And if we go to the 3D view, actually I'm gonna just run this script, and if you go to the 3D view and do Shift A mesh, and then you add object, that's the new thing that we just added, it adds the single plane. So now that we know what it does, let's have a look at how it does it. So this BL info is part of what makes it an add-on. Add-ons all need this special data so they can have a name and so forth and show up in your add-on list. And at the very bottom, add-ons all require a register and unregister function that get called when you add the add-on or remove it from your add-on, your active add-ons. And there's an operator right here, and that's a tool in Blender, and it has all the necessary things for it to work as an operator. It has a name, ID name, a label, some options. This is a scale variable that we're actually going to remove, and then finally an execution function that happens when you press the button. Finally, you have this add object button function that adds this operator into a layout as a button. And finally, this is just some documentation stuff. And finally here, you register that operator, telling Blender about it, and you add that button into the mesh add menu. So fairly simple stuff, but it would be very hard to figure it out on your own from all the documentation. That's why the templates are so useful to start out with writing your own script. And so let's see what we need to do to make this our add GNU add-on. First of all, the name doesn't have to be new object. We can call it new GNU, or add GNU, maybe. You can put your own name here instead of your name here. So I'll put my name. And instead of adds a new mesh object, I'm going to say adds a new GNU mesh. And the category can stay the same, add mesh. Now let's go down a little bit. Obviously we need to change what this list is and what this list is to actually get the verts and the faces of the actual GNU object. But we also want to change the names of objects that we're creating. So instead of new object mesh, I'm going to call this mesh simply GNU. And let's go down and just change these names to be nicer. So a new creates a GNU mesh. Let's call this add GNU. Add GNU mesh. I said I was going to remove this scale, so I'm just going to do that right now. I don't really need to be able to scale the GNU in the add-on. We can always scale it afterwards. The text here, instead of add object, should be add GNU. And that's basically it. Oh, let's actually remove the scale here, since I removed it down there. There's no scale anymore. So we're just going to delete these scale references. Our problem is that this is still just going to add a plane. Even though it's going to have the right name and everything like that, it's not going to add a GNU. It's going to add a plane. So we need to get our GNU into these two lists here. So the vertices have to be the vertices of our GNU mesh, and the faces have to be the faces of the GNU mesh. So let's go to 3D view, and let's click on our GNU mesh, and we could just go into edit mode here and click on a vert, and let's go show you text editor here for a second, and then copy these into this, and then keep on adding more verts one by one by one until we fill up the whole thing. The problem is that we have 679 verts to add, so that's a very long list to make. Similarly, when we go to the faces each have a list of the verts that make up that face, and similarly we have a lot of faces. We have 660 faces to add, so that's really going to take us too long to add one by one into our script. So we need to know a fast way of doing that. So I'm going to select the GNU, and I'm going to open a console window, and that's sort of a live coding environment that you can have inside of Blender. And let's have a look at building a list of these verts. So the concept that we're going to use to make this list, it's a new Python concept to some people. It's very cool. It's called a list comprehension. And let's explain how that works. So the list, first of all, is a basic data type. It's surrounded by square brackets, and it has some stuff in it. So here's this list of 4 numbers from 0 to 3. Now that's pretty easy to write, a list of 4 numbers. But what if you needed to make a list of 500 numbers from 0 to 499? Typing them all in by hand would be really slow, so we're going to be lazy, and we're going to write it out in a loop. So we could do something like this. We would say my list, and just start it out as an empty list, and then you would say in your loop, for I in range 500, my list dot append I. And then if you type out my list, you get your long list of numbers. Now that's pretty cool, but we're going to be even lazier and try to do that with just one line of code instead of writing 3 lines of code. And the way to do that is with a list comprehension. So you would say something like this: my list equals to, and you create a list, and then you put the for loop inside the list. So you say something like I for I in range 500. And so that's very similar to the earlier loop. And so what you're saying is you're taking every I and appending it into the list for I in range 500. But you're just writing that out almost in English here. And if you hit enter and you type my list, you get this big list of numbers again. And so we're going to use a list comprehension to grab the coordinates of every vertex in our GNU and put it into a list that you can then put into your text object. So let's do that. So we're going to create a list comprehension, and I'm going to say, and we can even give it a variable, so we can say GNU verts equal, and we're going to say it's, well, every item that we're going to add into the list is a vert, so I'm just going to say vert for vert in, and now we're going to grab where all the vertices are on the mesh. And first we need to know what the active object is, so that's bpy.context.object, or simply, because we're in a console, there's a nice convenience variable. Instead of bpy.context, you can type C, capital C, and that only works in the console. And this means from the active context, give me the object that's currently active. And since I have just selected the GNU head, it's going to give you the GNU head. And then that object has some data, which is mesh data in this case, and that mesh data has some vertices. And that's all we need. So if I hit enter and I type GNU verts, you can see I have a list of individual vertices, and you can see they have indices 677, 678. If you scroll up, you'll see it starts from 0. But I don't exactly have what I want, because I don't want the vertices as like items on a list. I want actually to have the coordinates of each vertex, or vertex rather. So to get the coordinates of a vert, you just type .co, and that grabs the coordinate of the vert. And now if I type GNU verts, I have a list of coordinates. And you notice they start with the word vector, and then they have a little list of numbers inside of them. And if we look back at our text editor here, we'll see that is exactly what we have here. So now we need to get this list, GNU verts, into this list called verts. And we could copy and paste it, but that would also be kind of annoying, and I told you that I was going to be lazy. The whole point of using the comprehension is to be lazy. So we're going to use a special function that Blender gives us to do this even lazier. First of all, I'm going to delete the bad list here, because we're going to replace it with a good list. And now I'm going to go down here, and I'm going to access this particular text object. So this is called Addon add object.py. I'm going to rename it to add GNU.py because it's shorter and it tells us what it is. And let's access it. So we can do bpy.data.texts and add GNU.py, and that gives us the text. Since we're in the console, we have a convenience variable here, which is capital D, that replaces bpy.data. bpy.data lets you access all the data in your blend file based on the type of data that it is. So if it's a text data, then it's .text. If it's 3D object, it's objects. If it's meshes, you get the idea. So this text object has a method called write, and if we hit tab, we can see that what it does. It says write text at the cursor location, which is right here, and advance to the end of the text block. So if I write hello folks here as my text, and I hit enter, you'll see that it wrote hello folks into the text object, which is really cool, but we don't want to write hello folks. So I'm going to delete that again and leave the cursor right there. What we want to do is get our GNU verts list added there instead. So instead of adding hello folks, let's try adding GNU verts. By the way, you could have written the comprehension right in those quotes, but since we added it to a variable, we'll just use that variable. So we got an error, and the error is kind of handy because it tells you what the problem was. So if you look at the error, you'll see you have something with a colon here, and that is an exception in Python. It's the name of the exception, and it's saying it's a type error. So this function write was expecting a string type, and we gave it a list. So we want to give the function not the list exactly, but basically a string of how you would write out that list. So-called the string representation of a list. There's actually a function in Python that almost all objects have to give you the representation. It's called repr, and so it's double underscore, which people usually say dunder dunder, or just dunder sometimes, repr, like that, and then it's a function call. The underscores are just some kind of Python stuff. It doesn't really mean anything that special. It just says that it's kind of a special type of function here. So if I use the repr, it will change the list into a string that looks like the list. And if I just hit enter, you'll see what I mean. It just basically added that huge list that we had made into our file. Way easier than trying to do it by hand. I'm not sure how long that would have taken us, and we probably would have gotten some numbers wrong. So the second step is to get the faces list updated, because if you run this script right now, which I'll just do because why not, always try things out, and do add GNU, our new function, we don't get anything that looks like a GNU. We get a weird face that's actually wrapped up in itself, and if we hit tab, you'll see what happened. Our GNU has all the right verts, but we never really added the right faces, and since we're just making one face and we're kind of connecting it in the wrong order, we get this weirdness here. Obviously not a GNU. So let's do the same thing we added there, but add the list of faces. So let's see how we get the list of faces of an object. So here we had c.object.data.vertices. The faces are stored in very similar way, but under polygons. And we'll just change the variables. Let's just call this F for short. And of course this is faces. Oh, our object is actually no longer selected. So I'll just select that. That's the c.object. And now if I do it again, and I type GNU faces, you'll see that we have a bunch of polygons from 0 to 659, those 660 polygons that make up the GNU head. Now we don't actually want the polygons one by one, we want the list of vertices that each polygon has. And that list is f.vertices, so just the vertices of a face. And if I write that out, it's just adding a dot vertices at the end of each line. And that's because we haven't actually made that into a list. And to do that, we're going to do something super sneaky. We're going to add a comprehension inside our comprehension. So instead of writing f.vertices, we're going to say vert for vert in f.vertices. Now, if we write this out, we have the vertex list of each face. So that's really handy. And if I jump up to, or just trying to find where I added, yeah, right here. So now we just need to add faces instead of verts, and let's make sure that we're adding the face list at the right place in our text. So we're gonna put our cursor here and delete this wrong list, and then we're gonna run this, and now we have the verts happily living, the faces, sorry, not the verts, the vert and the faces, in fact, happily living in our function. So if I run the script here, go to the 3D view, and now I'll left click and add a GNU, and you can see that we actually get a GNU, and we have more than one GNU in our file now, so it adds numbers at the end, but you can see that it has GNU as the name and of the mesh and the data, so it's really cool. And so as a final step, you can just do text save as and save your add-on, and now you have an add-on that you can you can go to user preferences, add-ons, and install from file, and you can find it here and install it and give it to your friends, and they can have a nice add GNU button in their Blender. So that's basically it. Really, hopefully a fun way to be really lazy and create an add-on without actually having to type out a lot of code. And I hope that inspires you to check out the other templates in the list of Python templates and see how you could use those and customize them for your own benefit. So that's basically it. I hope you enjoyed it and that you enjoy list comprehensions and adding primitives in Blender. Bye now.